All right, so let's go through some examples. These examples want us to describe the transformation that's occurring from the parent and then graph. And we'll graph 4 or 5 points depending on the problem. I do have one note up here. It says reflect over the x-axis first when necessary. So I'd make sure you write that down. We'll talk about it here in just a second. Okay, so number 1, the parent function is a quadratic. So the first thing I notice is we have a -1 out front. So this implies that we will be reflecting. We have a +4 that's on the outside of the mathematical operation of a square. So since it's on the outside, we're going up 4. Now here's why you need to reflect first. If you shift all of the parent function points up 4 first, then you're also shifting the reflection line up 4. So if you go up 4, the x-axis is no longer the reflection line. So you can do 2 things. You can either make a t-chart for this graph, which I'll do in just a second, or what I like to do a lot of times is I like to sketch the parent function. And I messed it up. So sketch the 5 points from the parent function and then use the transformation rules. So really all we have to do is count to graph the rest of this function. So for instance, let's just start at this point right here on the left. If we reflect it, its reflection is going to be 4 units below the x-axis. But then what we have to do is, after we reflect it across the x-axis, we have to go up 4 units. And then do the same thing for this next point. Reflect it over the x-axis, and it becomes this point here. And then we're going to count up 4 from this point. 1, 2, 3, 4. Do the vertex. You can't really reflect it when it's on the x-axis, so all we have to do is count up 4. And again, since there's symmetry with the parabola, we kind of already know where the other points are going to be. That doesn't seem easy to you, then you can also fill in the t-chart. So you can square these numbers, multiply them by -1, and then add 4. So if you square -2, you get +4. Multiplied by -1 is -4, plus 4 is 0. This is just another way to work out the problem. And those are ultimately the 5 points we have graphed. All right, so for the rest of these, I'm going to start by graphing the parent. So number 2, the parent function is a square root function. So I'm going to graph the points 0, 0, because the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So there's the parent function points. And then the first thing I want to take care of is we have a -1/2 on the outside as a multiplier. So the negative sign is going to reflect us across the x-axis. The 1/2 is going to compress the graph by a factor of 1/2. And really we're compressing, when we say by 1/2, we're compressing the y values. The y values are going to be the ones that are ultimately affected. And then finally, you have a +4 on the inside of that square root. So since it's on the inside, we have to go left 4 units, where that's the tricky one. Okay, so now I'm going to perform the transformations. So let's just start with this point here on the right. It's 3 above the x-axis, so its reflection is 3 below. So it's now here. Then we're going to compress the y values by half. So half of 3 is about 1.5. So it now is here. And then we're going to shift left 4 units from that point. So 1, 2, 3, 4. And then move to the next point. It's 2 above. We're going to reflect it. So it's 2 below. Then we're going to compress it by a half. So if we compress -2 by a half, it becomes -1. And then we're going to count left 4 units. 1, 2, 3, 4. And then this last one, it's 1 above the x-axis, so its reflection is going to be 1 below the x-axis. So it's 1 below the x-axis, but then we cut that in half because of the compression. And then we go left 1, 2, 3, 4. Oh, and the origin point, we can't reflect 0, 0 because it's already on the reflection line. And since its y value is 0, it can't be compressed. So all we have to do is shift that one left 4. And there's our answer. Whoa. I would encourage you to pause the video and try number 3. And notice I've started by graphing the parent function. That's the before. Your goal is to come up with the after. So those are the 3 transformations we need to perform here. It doesn't really matter which one of those 3 you do first. I always like to do the stretching part. To me, that's easier. And then going right 3 and up 1. But it doesn't matter so much since there's no reflection. So I'm going to take this first point on the left and stretch it by a factor of 2. So it's 2 above the x-axis. So now it's going to become 2 above the x-axis. And then from there, I'm going to shift that point right 3 and up 1. This next point is 1 above the x-axis. So when I stretch it, it's now 2 above the x-axis. And I'm going to go right 3 and up 1. This origin point can't be stretched since it's already on the x-axis and its y-coordinate is 0. So I'm just going right 3, up 1. And since this is a V-shaped graph, I know there's going to be symmetry on the other side of the graph. So I pretty much already know where these other 2 points are going to land. All right, question 4. This one's a little different because this time they give us that f of x is the absolute value parent function. So what does that mean? That just means they didn't write it, but f of x is equal to the absolute value of x. And then they say determine the equation of g of x, which is drawn below. So what we need to do is we have to figure out, okay, how is that shifted from the parent function? So I'm graphing the parent function just to kind of get a visual here. But then the rest is just counting to figure out what the transformations have occurred. It's pretty obvious a reflection has occurred since this graph is upside down. It's not been stretched, but as you can see the familiar over 1, up 1, or down 1, over 1 pattern with those points. But it has been shifted. And I kind of focus on the vertex to vertex. So how is that vertex shifted to the new vertex? We've gone right 3. And we've gone, it's like down 2. So they want us to determine the equation for g of x, And there's a couple of different ways to do this. We could rewrite g of x. Since it's been reflected, that means there's a -1 in the front of the absolute value symbols. We know there's a horizontal shift of right 3. So think about it. If it's a right 3, that has to be a subtract 3 on the inside. And down 2 means the 2 is on the outside, and it's also going to be negative. So that's one way to write the answer. The other way, and I think a way you'll see in a lot of your assignments, is they want you to write the g function in terms of the f function, which is basically the same way. We've seen this a little bit before already in previous sections. So both of those would be correct. It just depends on what way the problem is asking for you to write your answer. Okay, 5 and 6. It says f is a parent function and it has been shifted. It doesn't specify what type of parent function, just a parent, and it's been shifted 3 units left. So that is going to imply it's on the inside. 5 units up implies that's going to be on the outside, and it's been reflected across the x-axis. That implies there's a -1 multiplier on the outside. They want us to rewrite the function as g of x to show these changes. So this is what we just talked about. Since we don't know if this is absolute value or a quadratic or a square root, we're just writing a generic function, g of x, and we're writing it in terms of f. And like we said, 3 units left. That implies there's a 3 on the inside. It's going to be a +3. 5 units up. It's going to be a +5. And there's a reflection. Oh, so since there's a reflection, that means there's a -1. Means there's going to be a -1 out front. And we can just write it as a negative sign. That's all they want. I would encourage you to try number 6. Very similar to 5. So here's what I got. 2 units right. That implies that 2 goes on the inside as a negative. The reflection across the x-axis, that implies there's a -1 multiplier out front. But it's not just a -1 in this case, since we're also stretching the graph by a factor of 5. All right, and finally, these questions just want us to write an equation for each of the following functions. So number 7, that graph models the square root function. So I'm going to start it out like that. I don't know if I'll need a number everywhere in every single place, but I'm going to start it that way. And I can start number 8 in a similar manner. We have to figure out, based on the parent function, how has this graph been changed? So it's definitely been a down shift. We've shifted down, looks like 4 units. So that implies there's a -4 on the outside. Only question is, has this one been stretched out? And this is kind of tricky on this problem. It does look like it's been stretched out by a little bit, but it's kind of difficult to tell by how much. But what I'm looking at to get this answer is the parent function, so starts here And it looks like it normally goes right 1 and up 1. And it also goes right 4 and up 2. I really can't tell. I think the graph has been manipulated just a little bit. I'm going to put 1.5 here, again, because we're kind of just estimating there. Normally, I think it'll be more clear on a couple of these others. Number 8. So number 8, same story. Our parent function. You notice they only have one dot plotted there because that tells me there's probably not a stretch in this problem at all. Because really you need multiple points to tell if there's a stretch. So we've obviously shifted left. Looks like left 4 in this problem. And it also looks like the origin point has been shifted up 1. Of course, we've also got a reflection. Since this is upside down compared to the normal square root function. So the reflection implies there's a -1 out front. Taking care of that one. The up 1 means there's a +1 on the outside. And the left 4 implies there's a 4 that's also positive on the inside. I would encourage you to try 9 and 10 on your own. So here's what I get on number 9. The tricky part is this one was stretched by 2, and you can kind of see that by the dots that I've plotted there. Instead of going up 1 over 1, we went up 2 over 1. And number 10, again, the tricky part of this one was getting that multiplier out front. Oh, this one's a little more obvious than number 7 that we did together. Looks like there is a compression. So all the y coordinates have been shrunk by about half.